Do you feel like working a third shift at a call center for the next 5 years to purchase a monster truck you can use to grind your math textbook into dust? That's awesome. We can help you avoid those sleepless nights with this video from Fort Bend Tutoring and Mr. Witt.
Hello, ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about the zero factor property part 2. That's right. Dealing with radicals is going to be on the AP level, so get ready. And what we're going to look at first and foremost is a summary of all the problems that are going to be in this video. That's right. So you don't have to even wait for later on in the video to find out what you're going to get in this video. See, check it out. I got number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's right. 10 problems in this video for you. Okay, so we got the zero factor property part 2. If you need a refresher on some of the concepts that are going to be in this video, go ahead and check out our factoring with radicals video. AP much? Yeah, AP indeed. All right, let's get started with problem number 1. In problem number 1, we have 4x squared minus 6 equals 0. Well, one technique that we can use that we learned in the first zero factor property video is that if you have an equation set equal to 0 and you can factor it, then that will guarantee that you can solve for your variable. So normally when looking at this, you would have 4x squared minus 6 equals 0. Well, it appears to be in a difference of squares format, but of course 6 is not a perfect square. And lo and behold, you can start out by dividing everything by 2 to simplify the equation. In fact, I think I'll do just that. Let's go ahead and simplify this equation here. I mean, why are we dealing with these large numbers unnecessarily? All right, there's no need for that, right? So dividing every single term by 2, the GCF of the equation, we'll end up with 2x squared minus 3 equals 0. Oh, yes. This is a much more simplified equation, is it not? So noticing that all the terms were divisible by 2, we simplified the equation for the first step. That's what happened. Oh yeah. Now we have 2x squared minus 3 equals 0. But as I stated before, we're going to apply the difference of squares factoring pattern even though 2 is not a perfect square and 3 is not a perfect square. I'll factor this into x times the square root of 2 plus the square root of 3 times x times the square root of 2 minus the square root of 3 and set all of this equal to 0. Oh, let's straighten out the screen. There we go. There we go. Yeah, better? Yes. Because if you were to fold this back together, you would end up with the original. So notice that I took the square root of 2, which is the square root of 2, and of course the square root of x squared is x. I put that in front so it wouldn't confuse you, okay? See, I'm looking out for you, okay? And then I went ahead and did its companion binomial the same way. And I always leave a plus because I'm a positive person, okay? I'm an optimist. So for all you pessimistic people that factor the difference of squares with the negative first, I'll just continue to pray for you, okay? Because I'm going to start with the positive, all right? Because that's how I roll. So continuing on, we're going to set each factor equal to 0 and solve for it. All right, let's check it out. We'll have x times the square root of 2 plus the square root of 3. This equals to 0. Thank you. And we can also take the second factor, this x times the square root of 2 minus the square root of 3 equals to 0. So we set both factors equal to 0. And going back to our simplification on that first step, just to remind you that it's always okay to simplify your equation by a constant, meaning a number, but never simplify it by a variable. If you divide everything by a variable, you're eliminating one of your solutions. So never do that. All right, so let's continue on with this. We have 2 factors to solve for. So I'll begin by subtracting the square root of 3 to both sides of the equal sign using the subtraction property of equality. My additive inverses cancel out. I'll bring down x times the square root of 2, which equals negative square root of 3. Then I'm going to divide both sides by the square root of 2. Oh, yes, I am. Oh, yes, I am. You can't stop me. So now the square root of 2's will now simplify to 1, so I can write my result as x equals negative square root of 3 divided by square root of 2. But of course, we need to rationalize this, don't we? All right. So in rationalizing that by multiplying the numerator and the denominator by the square root of 2, we'll end up with a negative square root of 6 over 2. And that is one of our solutions. That's one of them. I'm going to go ahead and put a circle around this So keep up with that. And then we have our second equation, of course, right? So with the second equation, we'll be adding the square root of 3 to both sides of the equal sign. And this will bring down the x square root of 2 equals to the square root of 3. And then we'll just divide both sides by the square root of 2. Oh, yes, we will. Oh, yes, we will. We'll have x equals, after rationalizing, mind you, by the square root of 2 over the square root of 2, you'll end up with a square root of 6 over 2. And these are going to be our solutions for problem number 1. Yeah, let's go ahead and put this in a solution set so it'll look better. So let's say that x equals, let's go ahead and make a nice little brace, okay, because I cannot draw a brace to save my life. But today, I'm hoping that I can, oh no, see, there you go, see? That's what happens. The braces are ugly. The braces, no. Yeah, okay, we'll do with that because my braces are hideous. And then we will red box it. Oh, you got to protect that answer, see? Put a box around your answer. That's problem number 1. Yeah, that was problem number 1. Let's continue. Check out problem number 2. We have x squared minus 3x times the square root of 5 plus 10 equals 0. Now, one thing you should keep in mind is the fact that because we have the square root of 5 in here, and because our first and last coefficients are integral, then somewhere along the line, we're going to end up squaring this square root of 5, okay? So that means that out of this 10, you have factors 2 and 5. See, it's this 5 that we don't have to be concerned about. In fact, we can go ahead and go directly to our factorization of this trinomial here by including a square root of 5 in here. Yeah, you can. See, that's going to be taken care of. Don't even have to worry about it. In fact, we already know that x will be the first term here. So the only thing I need to be concerned with now is this 2. I need 2 factors of 2 that will add to give me 3. So when I'm dealing with factors of 2, of course, factors of 2, all right, we got 1 times 2. I mean, it's not a long list of factors now, is it? So I'm looking for 2 factors of 2 that will add because of the sign of the last digit in that trinomial. Yeah, I need those factors to add to 3. So it's going to be 1 and 2, right? So that means I'll use a 2 and 1, as I already have here, 1 square root of 5, thank you. And the signs must be negative because you see the sign of the middle term's coefficient, it has to be the same sign of the largest factor, always. And because I'm adding to get 3, this square root of 5 over there, it also needs to be negative as well. Yeah, it's factored now. It is completely factored. The product of this is our original equation. It's done. Yeah, it's done. So now that I have this completely factored, now I can set these bad boys equal to 0 and solve for them. So that's exactly what I'll do. I'll have x minus 2 times the square root of 5 equals 0. And then I will also take the second binomial and set it equal to 0 as well. So now we'll be solving for x in each of these equations. I'm going to be adding 2 times the square root of 5 to both sides of the equal sign. Yes, I will. Yes, I will. The additive inverses will cancel out. I'll bring down x equals 2 times the square root of 5. This is one of our solutions. In the second equation, I'll be adding the square root of 5 to both sides of the equal sign. Oh, yeah. Just like that. And I'll end up with x equals the square root of 5. And now we have x solved for. Yeah, it's the answer. We're going to go to the solution set now. Oh, the braces need help. There's nothing you can do. I mean, I feel you. I feel the love. I know you want to help me. I sense that. However, there's nothing that anyone can do. I've prayed about this. My braces will never be any better than what you see right here. I mean, no. Red boxing it. That's problem number 2, ladies and gentlemen. Oh, if you feel like I'm having fun, it's because it's true. I'm having a lot of fun right now. I love factoring. I love solving for the variable. I love manipulating the equation. Oh, yeah. I like to be in control. Give me a little problem. Where you think you're going? Problem number 3. We have 2x equals 3 times the square root of x. In order to use the zero factor property, I'm going to need to set this equal to 0. Okay, so that's exactly what I'll do. So I'm going to start by subtracting 3 times the square root of x to both sides of the equal sign here. Just like that. I'll be bringing down 2x minus 3 times the square root of x equals 0. And now, ladies and gentlemen, I'll be factoring out the square root of x. Yeah, see, the GCF in this binomial here, it's the square root of x. See, if I factor out the square root of x from the first term, I'll be left with 2 times the square root of x. The square root of x times 2 times the square root of x is 2x. Nice, right? Okay. And because of our original equation, there's a guarantee that our x value is non-negative. Okay. So otherwise, the original equation could not be possible because you can't take the square root of a negative number unless you're using complex numbers, which you may encounter from time to time. So unless stated otherwise, this is going to be all right. Don't worry about that square root. It's going to be just fine. Then, factoring out the square root of x from our second term, you'll have a negative 3. All right. And so now our equation is completely factored. We have our 2 factors, and now we'll set each factor equal to 0 and solve for the variable x. We'll have the square root of x equals 0. That's our first equation. The second equation will have 2 times the square root of x minus 3 equals 0. And now, in order to solve for the first equation, I'm going to square both sides of the equal sign. That's what I'll be doing. What are you doing over there? See, my square root and my square will cancel out. So I'll end up with x equals 0 because that's the result of 0 squared. Yeah, so this is one of my solutions already, is 0. Okay. For the second equation, I'll be adding 3 to both sides of the equal sign. Yep. Additive inverses cancel out. I'll be bringing down 2 times the square root of x equals 3. Dividing both sides by 2. We'll end up with the square root of x equals 3/2. Squaring both sides of the equal sign, we'll have the square root of x squared equals 3/2 squared. Oh yeah. Well, the square root and the square will cancel out so that x equals 9/4. All right. There you go. 9/4 is another solution. So therefore, our solution set is the following. We have 0 and 9/4. Oh, the hideous braces. Let's red box this. Red boxing it. And there's your answer for problem number 3. On to problem number 4. With problem 4, we have 405x squared equals 44. Yep. That's what we have. I'll begin by setting this equal to 0 by subtracting 44 to both sides of the equal sign. So that now we have 405x squared minus 44 equals 0. So I'm going to use the difference of squares factoring pattern in order to factor this binomial. I've already noticed that these 2 terms don't have anything in common. So let's go ahead and open up 2 sets of parentheses here. Setting that equal to 0. And taking the square root of 405x squared, I'll write it as x times the square root of 405. And this is going to be plus the square root of 44. Yeah, it is. And so I'll also have x times the square root of 405 minus the square root of 44. Now, understand, you will be simplifying these square roots. See, they're not in their simplest form, so you must simplify the square roots, all right? So don't think you're getting off easy here. You're going to have to do a little work. So we're going to look at the fact that 405 has as a factor the perfect square 81. Oh, yes, it does. And 44, its largest perfect square, is 4. So notice how in this first binomial here, I was able to break down the square root of 405 into 81 times 5, looking for that largest perfect square within 405. Then, as far as 44 is concerned, the largest perfect square within 44 is 4. And if you're not familiar with these numbers, then use your prime factorization to break it down and find the perfect squares within the number. That's what you do. That's what you do. I have x times the square root of 81 times 5, all underneath the radical sign there, minus the square root of 4 times 11 equals 0. Yeah, it looks a hot mess right now, but it's necessary. So we're going to go ahead and continue simplifying from here. Now we'll have 9x times the square root of 5 plus 2 times the square root of 11. See, it's looking a little better. It's looking a little better. Times 9x times the square root of 5 minus 2 times the square root of 11 all equals 0 now. Yeah, it's coming together. Now that we have everything completely factored and simplified, I'm now going to set each factor equal to 0 and solve for x. So we have 9x times the square root of 5 plus 2 times the square root of 11, this equals 0, as well as 9x times the square root of 5 minus 2 times the square root of 11 equals 0. Yeah, that's what we have. And so now in solving for x in both of these equations here, I'm going to subtract 2 times the square root of 11 to both sides of the equal sign. I now have 9x times the square root of 5 equals negative 2 times the square root of 11. Then I'll be dividing both sides by 9 times the square root of 5, like so. And because I want to make sure I don't have any radicals in the denominator, I'm going to be rationalizing by the square root of 5, the numerator and the denominator, to give me a result that is negative 2 times the square root of 55 divided by 9 times 5, which simplifies, oh yes it does, to 2 times the square root of 55 over 45. And this is one of my solutions. Oh yes. Yeah, there you go. Now, for the second equation. We'll start by adding 2 times the square root of 11 to both sides of the equal sign. The 2 square root of 11s on the left side will cancel out, so I'm bringing down 9x times the square root of 5 equals 2 times the square root of 11. Then I'll be dividing both sides by 9 times the square root of 5. Just like this. Now, you know we're not going to leave that square root of 5 in the denominator, right? So I'll be multiplying the numerator and the denominator by the square root of 5. This is so that we'll rationalize that denominator and get rid of the radicals in it. So we now have x equals 2 times the square root of 55 all over 9 times 5, and this gives us a result of 2 times the square root of 55 divided by 45, and this is another one of our solutions. So as a solution set, we'll have x equals, here comes an ugly brace, negative 2 times the square root of 55 all over 45, comma, 2 times the square root of 55 all over 45, and then finish with that ugly brace right there, and there you have your solution to problem number 4. Red box it. There it is. Just like that, ladies and gentlemen. That's problem number 4. Let's keep it moving. In problem number 5, we have 9x plus 9 times the square root of x plus 2 equals 0. And what we'll do here is recognize that our first and last term's coefficients are integral. So that just means that our first factors are going to have the square root of x involved. That's all. I'm going to open up 2 sets of parentheses here. Oh yeah, just bold and confident. I know that if I multiply the first times the last, I'll end up with 18. See, the first and last coefficients, I'm using the AC method here that I discussed in the factoring quadratic trinomials part 2 video. Go ahead and click on that link right there. Okay. All right. Okay. So we end up with 18. We're looking for 2 factors of 18 that will add to give us 9. Well, the 2 factors of 18 that'll add to give you 9 are 6 and 3. So I'll be doing the following. I'm going to use the square root of x as the first term. Oh yeah. I'm going to use 6 and 3, and both of these will be positive. Because I have a leading coefficient of 9, I'm going to divide both of these values by 9, and then I'll be simplifying. So I'll have the square root of x plus 2/3, because that's 6/9 reduced, right? And then I'll have the square root of x plus 1/3, because that's 3/9 reduced. And even though I can go ahead and set these factors equal to 0 and solve for it, I want to be clear, guys, that these 2 binomials will multiply to give you back the original. So that means I'm going to put my denominators in front of that square root of x. So I'm going to rewrite this as 3 times the square root of x plus 2 times 3 times the square root of x plus 1, and the product of these binomials will give me the original trinomial. All right, so I just wanted to make sure that you guys saw the finished form of the factorization so that you wouldn't have any issues with, well, hey, Mr. Witt, Yeah, I saw that previous step and you saw it for x and all, but the binomials don't multiply to give you back the original. Well, see, this one does. All right? It does. So now we're going to set each factor equal to 0 using the zero factor property. I can't wait. All right? Let's make this happen. We'll have 3 times the square root of x plus 2 equals 0. We'll also have 3 times the square root of x plus 1 equal to 0. And I'll be solving for x in each equation. This means I'll be subtracting 2 in the first equation here to give me 3 times the square root of x equals negative 2. And then I'll be dividing both sides by 3 so that I now have the square root of x equals negative 2/3. And now I'll be squaring both sides of the equal sign here. So in squaring both sides, let's see here, squaring this side, squaring that side. So x equals 4/9 maybe. All right. So be aware that since we have radicals involved, that there are going to be extraneous solutions from time to time. So you do need to check your results to see if they're going to work back in the original equation. Thus far, our previous solutions work just fine in the original equations. However, this may not. So before we check the 4/9, let's go ahead and solve for our second equation. We'll begin by subtracting 1 to both sides. We'll have 3 times the square root of x. This equals negative 1. We'll then divide both sides by 3. And so the square root of x equals negative 1/3. And then when you square both sides of the equal sign here, like so, you'll have x equals 1/9 when you finish squaring it. So we need to test 4/9 and 1/9 in the original equation. So remember, our original equation is 9x plus 9 times the square root of x plus 2. If we were to plug in 4/9, we'll have 9 times 4/9 plus 9 times the square root of 4/9 plus 2 equals 0. Well, our 9's will cancel out here. That'll give us 4. You'll have 9 times the 2/3 here plus 2 equals 0. From here, you'll have 4 plus 3 goes to 9 3 times. 3 times 2 is 6 plus 2 equals 0. And ladies and gentlemen, 12 does not equal to 0. So this doesn't work. 4/9 is not one of the solutions. Next, we'll try plugging in the 1/9, and we'll have 9 times 1/9 plus 9 times the square root of 1/9 plus 2 equals 0. From here, we know that our 9's will cancel out, so I'll bring down 1 plus 9 times the square root of 1/9 will give us 1/3 plus 2 equals 0. Next, we'll bring down the 1 plus we have 3 going into 9 3 times, so we'll bring down that 3 plus the 2 equals 0. And last time I checked, 1 plus 3 plus 2 doesn't equal to 0. It equals to 6. So since 6 does not equal to 0, that means that 1/9 is not a solution either. So it's another extraneous solution, which means that our answer for this problem is the null set. That's right, it's no solution, the empty set. In other words, this function does not touch the x-axis. So therefore, there won't be any x values that we can plug into the original function to give us a result of 0 for y. That's right, red box it. On to the next one. All right. For problem number 6, we have 14x squared plus 5x times the square root of 7 minus 3 equals 0. Since our first and last coefficients are integral, that means that we're going to eventually end up squaring that square root of 7, right? So if you look at 14, it has factors 2 and 7. Well, that means I only need to be concerned about that 2 right there, right? So the product of 2 and 3 is 6. So notice that I'm multiplying the 2 and this 3 right here to give me 6. I'm not concerned about the 7 right now because I know I'm going to end up with the square root of 7 times the square root of 7 to take care of that 7 right there. So we're only looking for factors of 6 right now that will subtract to give me 5. And those factors are 6 and 1. So let's open up 2 sets of parentheses, and set this equal to 0. So what I'll be using here is x times the square root of 7, x times the square root of 7, as well as 6 and 1. I know that the 6 needs to be positive because that's the sign of my middle terms coefficient, and I'll need a negative 1 here because the signs need to be different in order to subtract to give me a positive 5. Because we'll consider our leading coefficient 2 in this case, because we've already taken care of that 7 with our square root of 7's here, we will then divide both the 6 and the 1 by 2. And then we'll simplify this. So I now have x times the square root of 7 plus 3 times 2x times the square root of 7 minus 1 equals 0. So what happened in this step was I was able to simplify the 6 and the 2 to give me 3. And because I had a remaining denominator, I put that in front of my variable to get 2x times the square root of 7 minus 1. Now this finished factored form will give you the original equation. It's now that I'll use the zero factor property and set both factors equal to 0. So I have x times the square root of 7 plus 3 equals 0. And I'll also have 2x times the square root of 7 minus 1 equals 0. And now I'll be solving for x in each equation. I'll begin by subtracting 3 to both sides of the equal sign. I now have x times the square root of 7 equals negative 3. Then I'll be dividing both sides by the square root of 7. Oh yes. Now I'll be rationalizing the denominator by multiplying by the square root of 7 over the square root of 7. So I'll end up with x equals negative 3 times the square root of 7, all divided by 7. And this may be one of my solutions. Remember, we'll need to test this in the original equation to see if it works. In the second equation, I'll be adding 1 to both sides of the equal sign. So this gives me 2x times the square root of 7, which equals 1. I'll be dividing both sides by 2 times the square root of 7. Like so. And I'll be rationalizing that denominator by the square root of 7. Let's go ahead and squeeze that in there. And you'll end up with the square root of 7 divided by 2 times 7. And this is going to give us the square root of 7 divided by 14 as a result. And of course, we'll need to check this to see if it works in our original equation. All right, so let's check that out. So plugging in our first solution, and I'm going to use the first iteration of our solution, which was negative 3 divided by the square root of 7. We'll have 14 times negative 3 divided by the square root of 7 squared plus 5 times negative 3 divided by the square root of 7 times the square root of 7 minus 3 equals 0. From here, I'll bring down the 14, and squaring that negative 3 divided by the square root of 7, I'll end up with 9 divided by 7. Next, we can actually cancel out these square root of 7s right here, and 5 times negative 3 is negative 15 minus 3, and this equals 0. From here, we know that 7 goes into 14 twice, and 2 times 9 is always 18. So we have 18 minus 15 minus 3 equal to 0. And this is going to work because 18 minus 15 is 3, and 3 minus 3 equals 0. And this checks out just fine. So that means that our first solution, that negative 3 divided by square root of 7, or if you rewrite it as negative 3 times the square root of 7 divided by 7, that is a solution to the equation. Trying our second result, that square root of 7 divided by 14, we'll have 14 times the square root of 7 divided by 14 squared plus 5 times the square root of 7 divided by 14 times the square root of 7 minus 3 equals 0. All right. So we just plugged everything in. Let's see what happens. We'll have 14 times, this is going to be 7 over, I'm going to leave this as 14 squared for now, plus 5 times 7 divided by 14. And we got that from multiplying the square root of 7 times square root of 7 to give us 7. And of course, our 14 is left in the denominator. Minus 3 equals 0. All right. I do know that one of those 14s are going to cancel out. So in the denominator, we now have just 14 to the first power. Here we can simplify that 7/14 into 1/2. All right. Then looking at 5 times 7 divided by 14, we know that 7 goes into 14 twice, right? So this is now 5/2 minus 3 equals 0. Well, let's see what happens. We have 1/2 plus 5/2, that gives us 6/2 minus 3, which equals 0. And 6 divided by 2 is 3, so this is 3 minus 3, which equals 0, which works just fine. And since this solution also works, that means that both of our solutions will work in the original problem. So therefore, our solution set is going to be x equals, and I'm going to go try this brace. Oh, that's a decent brace. We can use that. Negative 3 times the square root of 7 divided by 7, as well as the square root of 7 divided by 14. This is going to be the solution to problem number 6. Red boxing it. Nice. All right, let's move on to our next problem. In problem 7, we have 7x squared minus 37x times the square root of 2 equals negative 20. Let's start by setting everything equal to 0 by adding 20 to both sides of the equal sign. All right, you'll have 7x squared minus 37x times the square root of 2 plus 20 equals 0. Now they're showing their hand by showing us the square root of 2. We know that 7 doesn't have a factor of 2, but 20 does. So that means that I'm going to show that that 2 within 20 is going to be taken care of by squaring the square root of 2. So that means that the only thing I need to be concerned about is the 7 and the 10 that remains. All right. So multiplying 7 times 10, what do we get? We get 70, right? So we're looking for 2 factors of 70 that will add to give us 37. Well, that's going to be 35 and 2. So using 35 and 2, we'll open up 2 sets of parentheses here. We'll be setting this equal to 0, of course. And I know that my second term will need the square root of 2 in there. Okay. Also, I'll need an x and an x here. And since we're using 35 and 2, it's the 35 and the 2 that both need to be negative because we need both of these terms here to add to give us negative 37. The only way they'll do that is if they're both negative. Because our leading coefficient is 7, we'll need to divide both the 35 and the 2 by 7. So here is our initial setup. I'm going to be simplifying now. So I'll have x minus 5 times the square root of 2 times, see, we can't do anything with that 7, so we're going to put it in front of the variable. That's going to be 7x minus 2 times the square root of 2, and this equals 0. And this is our factorization for our original equation. This will multiply to give us back the original. It sure will. Yep. Now, set each factor equal to 0 and solve for x. So we'll have x minus 5 times the square root of 2. That equals 0. We have 7x minus 2 times the square root of 2. This is equal to 0. And then we'll solve for x in each equation. I'll begin with the first equation by adding 5 times the square root of 2 to both sides of my equal sign here. Like so. All right. Those additive inverses will cancel out. I'll be bringing down my variable x, which equals 5 times the square root of 2, and this may be one of the solutions for x. In our second equation, I'll be adding 2 times the square root of 2 to both sides of the equal sign. I'll be bringing down 7x, which equals to 2 times the square root of 2, and then dividing both sides by 7, so x may equal 2 times the square root of 2 divided by 7. So it's these two solutions that we need to try in the original equation. So trying out our first potential solution, which is 5 times the square root of 2, let's go ahead and plug that into the original equation. So we'll have 7 times 5 times the square root of 2 squared minus 37 times 5 times the square root of 2 times the square root of 2 equals negative 20. Squaring out 5 times the square root of 2, you'll have 7 times 25 times 2 minus 37 times 5 times 2, and this equals negative 20. We know that 25 times 2 is 50, right? And so 50 times 7 gives us 350. Minus, this is going to be 5 times 2 is 10. 10 times 37 is 370. So here's the question. The question is, does 350 minus 370 equal negative 20? Well, it does. Negative 20 equals negative 20. So this works out just fine. So 5 times the square root of 2 is a solution to our original equation. Let's go ahead and try our other possibility. Now let's try plugging in 2 square root of 2 divided by 7. So we'll have 7 times 2 square root of 2 divided by 7 squared minus 37 times 2 square root of 2 divided by 7 times the square root of 2 equals negative 20. So now I'll be squaring that 2 square root of 2 divided by 7 squared. And we'll end up with 7 times 4 times 2 divided by 49 minus 37 times 2 times 2 divided by 7. And I'm getting this 2 here from multiplying the square root of 2 times the square root of 2, and this equals negative 20. From here, we're able to simplify this because 7 goes into itself once, 7 goes into 49 7 times, so we'll have 4 times 2 in the numerator, so that gives us 8 divided by 7 minus, so then we'll have 37 times 2, which is 74, and 74 times 2, so this is negative 148 sevenths equals negative 20. Subtracting 8 sevenths minus 148 sevenths, we'll end up with negative 140 sevenths equals negative 20, and when you divide negative 140 by 7, you'll get negative 20. This checks out. So we'll have x equals, brace, all right, we're going to pretend that's good. We'll pretend that's good. We'll have 2 times the square root of 2 divided by 7, as well as 5 times the square root of 2 as solutions to this problem. Red box it. That's right. Trap it in a red box. Done and done. On to the next problem. For problem 8, we have 50x squared minus 63 equals 0. These two terms don't have anything in common. However, I will be factoring this as though it's a difference of squares. So that means that I want to identify that the largest perfect square within 50 is 25, right? The largest perfect square within 63 is 9. All right, you see what I'm doing here? So that when I open up my 2 sets of parentheses in order to factor this, check me out. I'll have 5x times the square root of 2 plus 3 times the square root of 7. And so 5x times the square root of 2 minus 3 times the square root of 7 is going to complete the factorization of the original equation. If I were to multiply these back together, I would end up with that original binomial. I sure would. So now let's go ahead and set each factor equal to 0. So we'll have 5x times the square root of 2 plus 3 times the square root of 7. This equals 0. We'll then have 5x times the square root of 2 minus 3 times the square root of 7. This equals 0 as well. And now we'll be solving each equation. Oh yeah, and solving for x. So I'll be subtracting 3 times the square root of 7 to both sides of the equal sign. Lexo. I'll have 5x times the square root of 2 equals negative 3 times the square root of 7, and then dividing both sides by 5 times the square root of 2. Yep. So x equals, and especially after rationalizing the denominator here, so x would equal negative 3 times the square root of 14 all over 5 times 2, which is the product of square root of 2 times square root of 2, which gives us 10. So negative 3 times the square root of 14 divided by 10 is one of our potential solutions. In our second equation, we'll be adding 3 times the square root of 7 to both sides of the equal sign. We'll be bringing down 5x times the square root of 2. This equals 3 times the square root of 7, like so. All right. And then I'll be dividing both sides by 5 times the square root of 2 to both sides of the equal sign. And so you'll have x equals 3 after rationalizing 3 times the square root of 14 all over 10. All right. So it's just a positive version of this one right here. Okay. So that means, ladies and gentlemen, that this problem's done. Yeah. This problem is done. It's going to work on the original. It's going to work because we're squaring the values of x. So that means that x equals, let's get a decent brace. That's a good brace. Oh my God, that's a decent brace. That's like 1 in a million for me. It's going to be plus or minus 3 times the square root of 14 divided by 10. All right, the right side's not that good, but that left side is holding it down. That left side is holding it down. And red boxing it. That's right. That is the solution to problem number 8. Problem number 9, ladies and gentlemen. We have 20x squared plus 6 equals 13x times the square root of 3. We will be writing this in a standardized form by subtracting 13x times the square root of 3 to both sides of our equal sign here. That's exactly what we'll be doing. So now I have 20x squared minus 13x times the square root of 3 plus 6 equals 0. Yep, that's what we got. And now we're going to try to factor this. But first, let's pay attention to the fact that they have that square root of 3. So that 3 can only be found in the 6. So we just need to focus on the 2 and the 20. See, 20 times 2 is 40, right? So, are there two factors of 40 that will add to 13? See that last sign? Tells us to add to get the middle term's coefficient. So, we'll be using 8 and 5. Yep, 8 and 5. So, let's open up two sets of parentheses here. Let's get this thing popping. Okay, so we know that square root of 3 is going to be in play, all right? And it's going to be with that second term. So let's put it over there. We're going to need an x. Yep. And we're going to be using 8 and 5 to bring it home. Both values need to be negative. And because our leading coefficient is 20, we need to divide both the 8 and the 5 by 20. So it's now that I'll be simplifying this. So I'll rewrite it as x minus the 8 and the 20 can be reduced by 4, right? So that's going to be 2 square root of 3 divided by 5 times x minus the 5 and the 20 can be reduced by 5, right? So we'll have the square root of 3 divided by 4, like so. And any remaining denominators will go in front of the variable. So we'll rewrite this as 5x minus 2 times the square root of 3 times 4x minus the square root of 3 equals 0. And this is our original problem, completely factored. From here, we'll be setting each factor equal to 0. So we'll have 5x minus 2 times the square root of 3 equal to 0. We'll have 4x minus the square root of 3 equal to 0. And we'll be solving for x in each equation. So that means I'll be adding 2 times the square root of 3 to both sides of the equal sign. Oh, yes, I will. Oh, yes, I will. What you gonna do? How you gonna stop me? You can't stop this. I'm dividing both sides by 5 now. All right, so let's make this happen. So one of our potential solutions is, let's get it in view, is 2 times the square root of 3 divided by 5. Maybe. That may work. It just might. In our second equation, we're adding the square root of 3 to both sides of the equal sign. To both sides of the equal sign, we have 4x equals the square root of 3. We'll be dividing both sides by 4. Oh, that's an ugly 4. Fix it. Fix the ugly 4. Fix the ugly 4. Better. Much better. The 4's will cancel out. We'll have x equals the square root of 3 divided by 4. Maybe. See, we'll need to test these in the original equation. So let's do that. So let's check out 2 times the square root of 3 divided by 5 in our original problem and see if that works. 2 times the square root of 3 divided by 5, we would have to square that. Plus 6, this is supposed to equal to 13 times 2 times the square root of 3 divided by 5 times the square root of 3. So let's see what happens in this problem. We will end up with 20 times, this is going to be 25, this is going to be 4 times 3, plus 6. Over here we'll have 13 times 2 times 3 all over 5. Yeah, doesn't that look lovely? From here, we're going to simplify this by 5, the 20 and the 25. 5 goes into itself 5 times. 5 goes into 20 4 times. And if I were to multiply that together now, 16 times 3 is going to be 48. We have 48 fifths. Thanks. Plus 6 written as a fraction is going to be 30 fifths. Okay. So that means that if we multiply 13 times 6, which is going to be 78 fifths, does this left side equal to the right side? Yeah, it does. It does. Ladies and gentlemen, the 2 square root of 3 divided by 5 is a solution to this equation. Yeah, it is. Let's try the other one. The square root of 3 divided by 4. So we'll have 20 times the square root of 3 divided by 4 squared plus 6 equals 13 times the square root of 3 divided by 4 times the square root of 3. Okay. So what happens is we'll have 20 times 3 over 16 plus 6. This equals to 13 times 3 divided by 4. Well, in simplifying this, 20 and 16 can both be reduced by 4, right? So 4 goes into 25 times, 4 goes into 16 4 times. We'll end up with 15 fourths plus 24 fourths. This equals 39 fourths. So does the left side equal to the right side? Yes, it does. 15 plus 24 is 39. So you'll end up with this being the correct answer as well. So there you have it, ladies and gentlemen. Our solution set is x equals, we're going to deal with that, square root of 3 divided by 4 and 2 times the square root of 3 divided by 5. There you go. These are the solutions to problem number 9. Red box it. Red boxing it. There it is. That's problem number 9. And now our final problem, problem number 10. In problem number 10, we have 21x squared minus 17x times the square root of 3 plus 6. In this problem, ladies and gentlemen, it's going to be a little different because our square root of 3 that's showing his hand right now can be found either in the 21 or the 6. So let's go ahead and see if we can get the correct answer doing it 2 different ways. That's right. That's why this is called 10A, because I'm going to show this problem 2 different ways. So in the first way, I'm going to show that 21 is 3 times 7. So that means that we're going to focus on 7 times 6 to give us 42, and we'll need 2 factors of 42 that will add to give us 17. We'll see, that would be 14 and 3. So that means I'm going to set up my equation as, open up 2 sets of parentheses here, like so. I'm going to have x times the square root of 3 first for the first term, and I'm going to use 14 and 3, knowing that both values need to be negative, and because we had a leading coefficient of 7 in this case, we'll divide both values, the 14 and the 3, by 7 and simplify. This will give us x times the square root of 3 minus 2, and it'll give us 7x times the square root of 3 minus 3 equals 0, and this is going to be my setup for problem 10A. Oh yeah. We're going to set both factors equal to 0 and solve for x. So we'll have x times the square root of 3 minus 2, this equals to 0. We'll have 7x times the square root of 3 minus 3, this equals to 0. And then solving for x in our first equation, we'll add 2 to both sides of the equal sign. This gives us x times the square root of 3, which equals 2, and then divide both sides by the square root of 3, and then rationalize it. We'll have x may be 2 times the square root of 3 over 3. This is one of our potential solutions. For the second equation, we're going to add 3 to both sides, like so. We'll have 7x times the square root of 3 equals 3, and then dividing both sides by 7 times the square root of 3, and then rationalizing that. Oh yeah. Okay, we'll have x equals 3 times the square root of 3 divided by 7 times 3, which simplifies to the square root of 3 divided by 7 as another potential solution. There it is. So let's test these out to see if they work. So let's get to it. Oh, and by the way, in the original equation, this is equal to 0, guys. All right, that should be equal to 0. Equal to 0. So trying out our first solution, which is 2 times the square root of 3 divided by 3, we'll have 21 times 2 times the square root of 3 divided by 3 squared minus 17 times 2 times the square root of 3 divided by 3 times the square root of 3 plus 6 equals 0. Squaring that 2 times the square root of 3 divided by 3, you'll have 4 times 3 divided by 9 minus 34 times 3 divided by 3 plus 6 equals 0. We know that 3 goes into 9 3 times, 3 goes into 21 7 times, and then 7 times 4 is 28. These 3's cancel out, so I'll bring down the 34 plus 6 equals 0, and 28 minus 34 is negative 6, and negative 6 plus 6 is 0. 2 square root of 3 divided by 3 works. That's a solution to our equation. Trying out our other potential solution, we have 21 times the square root of 3 divided by 7 squared minus 17 times the square root of 3 divided by 7 times the square root of 3 plus 6 equals 0. When we square the square root of 3 divided by 7, we'll have 21 times 3 divided by 49 minus 17 times 3 divided by 7 plus 6 equals 0. I know that 7 goes into 49 7 times, 7 goes into 21 3 times, so this is 9 sevenths minus 51 sevenths, and then rewriting 6 with a denominator of 7 will give us 42 sevenths equals 0. 9 minus 51 is negative 42, and negative 42 plus 42, it's 0. This works just fine. It works just fine. Therefore, the solution to problem 10 is square root of 3 divided by 7 and 2 square root of 3 divided by 3. All right, red boxing it. This is our answer for problem number 10A. All right, but I promised you that there is another way to solve the problem. Let's check it out. So approaching the problem the other way and saying that the 3 that you're going to end up squaring is within the 6. In this case, we would focus on the 2 and the 21. That still gives us an overall product of 42. So we're still going to be looking at 14 and 3 to combine to give us the negative 17. However, our setup will look different. All right, because in this problem we'll have x, we'll have our square root of 3 here, we'll have our square root of 3 here, but you'll be putting the 14 and the 3 there, and once again the 14 and 3 must be negative, and you'll divide both of the values by 21 in this case. Okay, let's not forget this x right here. So we can simplify from here. We'll have x minus reducing the 14 and 21 by 7. This is going to be 2 times the square root of 3 divided by 3, which looks familiar, right? And then we'll reduce the 3 and the 21 by 3, so we'll end up with x minus the square root of 3 divided by 7, which looks familiar, correct? And then setting each factor equal to 0 and solving for x, we'll have our final results of x equals 2 times the square root of 3 divided by 3, as well as x equals the square root of 3 divided by 7. And we already know that these two values will work just fine in the original equation. They're both solutions to the original equation. So therefore, red box it. And this, ladies and gentlemen, completes our video on the zero factor property, part 2, dealing with radicals, AP much. So hopefully you learned a few things by watching this video. And as always, please rate, comment, and subscribe. And if you're able, please donate, as that helps us make more free math tutorials from Fort Bend Tutoring and Mr. Witt. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.